The Burnstone mine was opened in July 2007 to extract gold from a narrow tabular ore body between 260 and 750 meters below the surface. This project boasted a valid alternative to high-cost, deep-level mining in South Africa by developing a highly mechanized mine rather than the conventional, labor-intensive methods that puts miners with hand-operated drills on the rock face and in dangerous situations. Being a shallow and somewhat small mine means that refrigeration and other expensive infrastructure is unnecessary. The mine has been designed to allow access for large vehicles, machinery and equipment required for the mechanized process, either through the 480-meter vertical shaft or the decline shaft. Join us as we take a closer look at how the Burnstone mine operates. The on-reef development happens within the ore body, and that means even access development contributes revenue from the gold recovered. The primary high-profile accessways are developed first. This divides the reef into blocks or sections, all connected to the decline and vertical shafts. Every part of the development and production cycle is entirely mechanized using high and low-profile vehicles and machinery. The principal vehicles used are drilling rigs, roof bolters, loaders, and dump trucks. The first part is the development cycle, which prepares the reef for stoping. The drilling rigs bore holes for blasting, which are primed with emulsion explosives. After blasting, the loaders then clean out the area, load the rock onto dump trucks, and make way for the roof bolters to move in and support the hanging wall. After the primary high-profile accessways are constructed, the smaller, low-profile accessways are created using the same process, further dividing the reef into the stope blocks where the mining will take place. The mechanized process allows very accurate and efficient stoping of the fairly narrow reef. The ore body at Burnstone is at a relatively flat angle, and the mining method used for the excavation of ore is long hole stoping. In conventional mining, most accidents happen during stoping, but at Burnstone, this operation does not require any employees to enter the active stopes. So by using the mechanized process, not only is the mining more efficient and accurate, but much safer. The stoping process starts with the support installation, where the bolters secure the hanging wall with long anchors. This is followed by stope drilling, which bores 20 meters into the ore, each hole half a meter apart and primed with emulsion explosives. The explosion and slope drives the ore into the lower accessway, ready for the low-profile loaders to move it into the mucking bays. There, the high-profile loaders move the ore onto large dump trucks, ready to be taken to the surface for processing. High-pressure, low-volume water jets then clean out the blasted areas, and the stoping cycle is repeated. The mechanized process allows for rigs to be continuously operating, so stoping can happen in multiple areas of the ore bodies simultaneously. So while traditional blasting advances about 0.9 meters per day, at Burnstone we advance 5 meters per day. The stoping process is repeated until each block is depleted of ore, leaving only a support pillar in the stope. Waste rubble is then packed into the stoped out areas, saving even more costs. Burnstone has been intensively developing the ore body and has finally begun stoping, extracting ore for processing. The project has achieved several significant milestones, including the commissioning of the metallurgical plant, which was completed on the 1st of October 2010 and had its first gold pour 30 days later. 13,239 meters of on-reef development has been completed with good consistency in the continuity and values of the exposed reef. We are thrilled to have seen this Burnstone project develop into an efficient, safe and highly productive mine that promises great returns for the years to come.